Hello. Okay, so we're back. Let's go through an actual. So what we'll do, we'll take the vulnerable code. Then we'll use that. Okay, so I'm just gonna create a directory here. YouTube. And come here. I'm gonna create the buffer. Okay. Create a C program. And then we have to compile it quickly. Buffer like that. Okay, there we go. This will compile it. Have a look. There it is, yeah. Now what we're gonna do, we're just gonna change. We're gonna change permission to root. Okay. Now we need to change permission to root because basically an actual exploit happens when a program on Linux runs with a SUID of root. When you buffer overflows that program, it will actually give you root access. So people usually buffer overflow program that runs as root to gain root access. Alright, so now just need to make this, need to change permission. Now if you have a look, you'll see that this program is owned by root and it's got a sticky bit of root. So when this program gets overflown, it will give us root access. And as you can see right now, I'm my own user. Okay, so what we'll do, what we're gonna do, okay, first we need to understand where does the input comes from. Okay, so input comes from, on the same line, obviously, because of the argument. Okay, so we know that, that's fine. So now what we'll do, we will, okay, this is what we can do. Okay, we'll use GDB debugger, program debugger, and we run the program in GDB. Okay, now what we can do, we can run the program, or you can deassemble this to see how it looks like. These are assembly codes that are happening here, pushing things into registers and so forth. And you can see this is where the full function get called. Okay, so now what we'll do, we will run the program, but then because we need to fuzz this program, we need to use a fuzzing method to actually find where is the buffer overflow. Okay, so we can use it like this. We can do Python commands, right? Okay, so here we're gonna use the hexadecimal value of A is 41. We'll do okay. Okay, let's have a look here. Okay, so we've got 12 bytes. Okay, 12 bytes. So actually we are allowed 11 plus 0, so it's 12 bytes. So we'll start fuzzing this from 13. We'll say okay, give us 13 here. Run it. The program runs and successfully. Okay, so we need to carry on. Program still runs successfully. 15. Still run successfully. 16. Still run successfully. One int, that you need to have as well. We're using a 32-bit architecture machine. On a 32-bit architecture machine, memory bytes are read in four bytes per sequence. So 5 times 3, that's 4 times 3, that is 12. So then you want to do 4 times 4, 16. So basically, yeah, this is our next one. So the next one that you want to do, you want to do 20. So you just increment by 4. Okay, and boom, you can see we've now overwritten something. And this is the EBP that we've overwritten. We haven't overwritten the return address yet. We have now overwritten this space here, the EBP on green. Let's go back. Let's increment by another 4. We're still within the EBP. Another 4. Oh, sorry. Another 4. Now we have overwritten the return address 41, 41, 41, 41. Now this has been overwritten, the return address. Program doesn't know where to return to. That's what we want. But we need to make sure that we got the right offset. So we'll do 24. Plus we add a different character, 42 times 4. Remember, 32-bit memory is read in 4 bytes. Okay, so we do this. Now, if I got it right, we should have 42 being printed here, not 41. So, when we go like that, there you can see how we got 42 here. So now we really control the return address. So what we'll do, what we want to get here, we want to get the address of the address of the stack at the top of the stack, which is this here, 630. But we're just gonna confirm it with this command, info frame, and you can see EIP now points to that memory address. Okay, that's where it points to. This is the top of the stack. You can even see it here. ESP, that's the top of the stack. It's pointing to that. So we want this memory address because we want to use that, to carry on our exploitation. So then what we'll do, we'll just open up another window. Let's open up this window. Then we go to YouTube. Oops. Yeah. And we will now create a file. Okay, we're gonna exploit from this file first, a Python file, and then we'll say, okay, I'm just defining random variables here. So I'm saying 41 because we know 41 times 24. That brings us to the right offset. And then we know that okay, so we're gonna call this something added. Okay, we'll say add. Okay, just to make sure that we're still good. Oh my god. Do that times 4. Yes. Then we say print heading plus add. Like that. Okay, so this code basically, I'm defining this variable, I'm defining that, and then I'm printing it. Exactly like that, one after the next. This one first and then that. So that's basically what I did from the command line. But now we need to put it nicely in a file because we're gonna carry on the exploitation from here. So I want to do this, and then what I can do, I can just run Python against it like that. Then I'm gonna put it in a file this way. There it is. Then go back here, and then I can switch. Let's run it again, and then we're gonna say run, and then we wanna do and then we wanna do this. Then we're gonna do cat exploit. Okay, this will give us the same results that we had, C4242, because now it's reading it from the file. Alright, so remember the memory address, the memory address of the top of the stack, which is this one. That's what we want to use. So we'll actually, you know what? Let me make this. Let's more like that now. Then say this. make it smaller as well. Yeah, make it run. Let's do this. Okay. Nice. So now, what we'll do, we'll come back here to this file. We'll say, instead of printing 42, we're now gonna say EIP equals struct.pack, and then we need to say I for 32 bits integer space. Oops, I want to go to this value. Just before I carry on, I need to import struct. Okay, so we're importing this module called struct. It's a Python module which allows you to jump, into memory addresses. Yes. And then okay, so we got that. So we're saying, okay, pad up until the offset, and then return to a valid address. But then I want to add no operation 100 times as an example. Okay. So now we'll say print. We'll say print padding first. Define my return address where I'm coming back to, and then run this code. That's what we're doing. Do that, and we put it in a file. Okay, and we come here, and now we will say run. Now when we run this, you see it ran. It gave us all these 90s, which are this, okay, this line of code. Okay. Now what we want to do, we want to examine the memory and get a valid address that points to one of these ops. Okay, because that's where we're gonna point back to. So we're gonna say examine 200 bytes in Word and hexadecimal from the ESP, from the stack. So from the top of the stack, it's gonna look at this, and we're looking for a valid address somewhere in the middle of this, where we will insert our shell code. And there we go. So enter. Then we go back up, looking for the 90. Where's the 90? Where are you hiding? Okay, here it is. Now you can see these are my padding, 41, 41, 41. Then these are my 90s right here. What I want to do, I want to get a value in between here that we're going to return to. Now this is a valid address in memory, so we can return to that. And that's what we want to use because we control all this area with no operations. And our shell code will reside here. So you say, okay, now instead of going back to the initial one, we want to get back here. Okay, we want to get back here. Then just for a test, we're gonna say, okay, cool. We're gonna insert a sig trap. Sig trap is just a signal trap. That's what it means. It's something that you can inject into the CPU to basically pause the execution of a program. So we just want to execute this to make sure that we can actually inject the code here, because then in a later stage we'll change that to an actual code. Yeah. So we do that, and then we say no ops plus the code. So this will do padding. It will set my return address to this, and then it will obviously still have the no operation there. And then we've got the code that we want to execute. So we save that, we send it here, and we can restart from scratch. Now when we run this, we need to get a seek trap to make sure, that will tell us that we actually getting code execution. Run it. As you can see, we've got a seek trap, code execution. Okay, and where is the memory? Okay, let's go back here. 630. Let's go back up. Okay. Alright, so we got a seek trap, which is good. As you can see, my no operation, and then it went on to it went on to an address and executed my seek trap. So now that we know we can seek trap, what we'll do, we'll put an actual code which I can get. I'm gonna get and you can get a bash code from Shell Storm, but I've got it already here on one of my previous exploits. There it is here. We're going to use that code. This code is a bin bash code, giving us terminal access on a Linux machine. Okay, so what we'll do, we'll now replace this with the code execution that we want. Alright, we'll save it, put it in a file. You can quit this, we come back. Now when we execute, it should execute our code, which is the bin bash. We run it, there we go, code has been executed, bin dash, new program, we go to terminal, who am I? Okay, yeah, because we're on GDB, it's not executing it properly. But okay, now we got execution. So what we can basically do from here, we can use this. Now let me put it properly here, because now this is the moment of truth. Do that. Okay. Now what this will do, we will get whatever that's in our exploits, which is our final product that we've got on here, and then we'll leave it open with a cat, and then we're going to run the program into this. So when we run that, okay, now we into cat, and when we go, who am I? Oh my god, got a segmentation fault. Okay, so there's two ways you can run this. You can run it with cat, or you can actually run it like this. Yeah, you can run it like this. So you execute the program, and then you put your Python script. I'm sorry. Let's do it again. You can run it like this. So no, like that. Yeah, like this. And then here I'm gonna have my exploit, and then I run, and who am I? Oops, there we go. So now, yeah, this way it works. So we're executing the program, and then we're pushing our exploit there, and as you can see, we've got root access onto the machine. And yeah, so yeah, I think I kind of figured out how this buffer overflow works here, but I'm still learning, because I really want to make sure that we got a very good, proper understanding of it. Okay, on my next episode, I'll show you how to exploit this on the Windows machine. and that will be a remote exploitation. Okay, cool guys, thanks.